Hello Math 1680 students, let's have a review session for Exam 1A. I'm going to use the actual exam problem I wrote, and this was written for the summer of 2020. Problem goes like this. I gave you a data set for problem number 1, and problem number 1 is a descriptive statistics, box whiskers chart, histogram, and regression. And then problem number 2, we have some Venn diagram and probability. Problem number 3, discrete probability distribution. And finally, number 4, normal probability distribution. We're going to review it in the order of importance. So let's begin with number 4, which I think is the most important. Okay, let's begin. According to a study by cadets of U.S. Air Force Academy, the number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is approximately normally distributed, with a mean of 1,262 chips and a standard deviation of 118 chips. Okay, this 1,262 and 118 must have come from experiments, and they must be average value, but for this problem, let's just take those for granted. We call those kind of thing bootstrapping. Okay, all right. Let's answer the question. What is the probability that is randomly selected? What is the probability that a randomly selected 18-ounce bag of Chips Ahoy cookies contains more than 1,500 chocolate chips? We have to answer this question, and then you have to show your work. But most importantly, you have to complete the picture. If I did not give you the outline, maybe you can get away with not picturing as long as the others are all correct. But if I did give you the outline, then the picture is absolute necessity, and that's where we are going to start. Even if I did not give you the outline, please start with a picture. It will be really, really helpful. Okay, here we go. Here's the standard process: outline, center, end, and shade. So we have the outline, and center is the mean, 1,262. Now let's go to the end. The problem explicits that 1,500. So where's the end? To the left or to the right? In mathematics, right is bigger, left is smaller. 1,500 is bigger than 1,262, so it goes to the right. So we have the end at 1,500. Center, 1,262. And finally, let's shade. This problem is more than 1,500, so we have to shade to the right. In math, more than is right-hand side, less than is left-hand side. So shade or right. We are looking for this red area. Clearly, you're looking for something small here. If you calculate and get something like 70%, something is completely wrong because it's certainly less than half. So if you shade entire right-hand side, that's just 50%. It's a lot less than 50%. So if you get something really high, then something is badly wrong. Okay, let's begin. The computation follows from this important formula: z equals end minus center over SD. And later we're going to change it into end minus center over SE for standard error. But before the first exam, let's begin with SD. And this is another form, but I don't like it very much because there are so many different variations of this. Sometimes we use x minus x bar, sometimes x bar minus mu, and we use s over sigma or sigma over square root of, oh, there's so many different variations of this. So it's really hard to track this down. Better this way: end minus center over SD, and that depends heavily upon the picture. End is 1,500, center is 1,262, and the SD is given as 118. That gives you this computation. Okay, you got the z-score of 2,002, approximately speaking. you have 69 something, so 2.02, and you can use statistical calculator if you know how to use it. Or let's go to the standard method. Let's go to the table. Of course, this table will be provided for you here. And how do you find out? Let's go to the z-score of 2.02. All these are negatives, so you'll have to go to the next page. 1 point something, go down further. 2.0, okay, here we go. 2.00, 2.01, 2.02, here we go. 0.9783. So that is the probability, but that's not the probability you're looking for. Go up and look at the picture. That's what these numbers are. The shaded to the left, the blue part. And 97.83% is the big part. Let's go back to the picture we have. We're looking for this right-hand side. So 93 something, what is 97 something? What was the 0.9783? Yes, 0.9783 is this part to the left. So how to get to the right-hand side? We need 1 minus of that. So 1 minus of 0.9783, that is the probability you're looking for. Approximately speaking, 0.0217, or if you prefer percentages, 2.17%, or any kind of reasonable approximation of this will be accepted as full credit. 2.2% or 0.22 or just 0.2, anything close, I'll give you full credit. Now, if you read your table incorrectly, that's going to be a deduction. And then if you fail to subtract from 1 and then get something ridiculous, that's going to be a bigger deduction, because look at the picture. Clearly, this is very small probability. Clearly, if you get more than 50% with this small shading, I regard it as total lack of understanding. So if you stop at 0.9783, all computations that everything is correct, you read the table correctly, looks like you're just one step away from correct answer, but no, I regard it as pretty close to 0 credit. Because look at the picture. This doesn't look like 97% something. So here we go. Which is more important, the picture or the computation? Picture is more important. By the way, here's a full justification. This is the cumulative distribution function, and then by taking this rescaling, by taking the z-score, you're pushing it over to standard normal distribution. And that's the justification. If you're not really interested in the justification, just stick to picture and the z-score computation. Let's see, do we have enough time for the next problem? Let's go. No, not this problem. Here we go. Determine the 15th percentile. Again, I gave you the outline, so it's very important you provide a picture. Let's go back to my notebook. 15th percentile. And how do you draw the picture? Again, the same process. Outline provided. Center, you have to mark. You have to mark as 1262. That's easy, that's a mean. And shading associated to 15th percentile. How do you do that? If you're going to try on your own, stop this playback and then do it. Well, here we go. 15th percentile, we need about this much. 15% should be the left. So if you get something bigger than the mean, then of course you're getting something bigger than 50%. That's ridiculous. And about 15%, all right, about this much, that looks kind of appropriate. You don't want to get something really close and get something like 40% of the size. About this much looks good. And then you have to use the same formula, n minus center over SD, but this is going to go backward. Because, you see, you don't know what this x is. You don't know the end. But you know the z-score. You see? The n minus center over SD is the z-score associated to that 15th percentile. And I claim it is negative 1.04. Well, let's check it out. Let's go to our z table. And where is 15th percentile? Let's check. You see, all these numbers here are probabilities. So we have to find out something that is closest to 15%. And the first page, we have all those less than 50%. Second page, all those bigger than 50%. 15% is 0.15, so it should be in this first page. And 15%, 0.15, where is it? Well, here we go. 0.1515, 0.1492. Well, what's closest? I would say 0.1492 is closer, and excuse me, this number, and that corresponds to negative 1.0, and the second decimal is 4. So negative 1.04 is my z-score. Negative 1.04 is my z-score. You see, that came from your table. N minus center over SD. You don't know the end. Center you know. And then SD is given as 118. So putting everything into that computation, here is your equation. N minus center over SD is z-score of negative 1.04. Let's solve this. Multiply this denominator to the other side, we get this multiplication. And then flip this to the other side so that you add the result, 1262 minus 0.04 times 118. And if you run your calculator, you're going to get 1139.28, approximately speaking. Everything is approximate in stats, so I'll conclude it as about 1139, or maybe even 1140. If you want full justification, you can go ahead with this 15th percentile being pushed over to the rescaling, and then this normal distribution in general centered around 1262 is being pushed over to standard normal so that you can look up the table. If you're not too much into justification, just skip this part and you can stick to the picture and the z-score computation. So do you feel comfortable with z-score problem? We went through a forward problem where we draw the picture, of course, and then we know the end. So we can calculate the z-score through n minus center over SD. From the picture, we know the end. Problem gave you the end. So n minus center over SD, you can calculate the z-score. And then go read your table. 2.01 something. Read your table, get your probability, and work from there. Here, right hand side, so you have to subtract from 1. If the problem said less than, then of course shading will be over here, so you don't have to subtract. Well, there are various problems like this in my math class, so I'll just leave you there. And the second problem is backward. Go to the picture, and then you don't know the end. You know the area, so you can find out the z-score, but don't know the end. So how do? You get approximate z-score from the table and then set up the equation, solve it, and then you get the estimation.